Welcome to MRU E-Learning, powered by Mallaradi University. I, Dr. Zamir Gulda, Associate Professor in the Department of AI/ML, School of Engineering, Mallaradi University. So today we are going to discuss something which is inevitable in academics as well as in other domains also. So our agenda for today's session is machine learning. We'll go with the definition of the machine learning. What are the different perspectives of machine learning? How machines actually learn and how to build a model. If we go with the machine learning, the first definition is that it allows a computer to learn from examples or the past data so that they can make the decisions or the predictions without being directly programmed for every task. There is one more definition. Machine learning means teaching a computer to recognize patterns just like we humans do. Machine learning is when computers learn from the data to improve their performance automatically. So you can come across various definitions of the machine learning. Why it is so, why we are having different types of definition, why not a common definition over there? That is why we want to know the perspectives of the machine learning. Machine learning is not a single discipline. Okay, it's used in every domain and it is understood by computer scientists from their perspective, statisticians from their perspective, data scientists, cognitive scientists and engineers. So they want to use machine learning in their own way. That is why you are going to see different types of, different perspective, different definitions of the machine learning. These viewpoints, these perspectives, they will help us to design a machine learning system very well. Now, let us understand why we are having such perspective. Machine learning can be seen as a mathematical problem by the mathematicians and a computational process by others, a data-driven approach by the data scientist, and a biologically inspired system by the biologists. So, it sits between maths, algorithms, data, human learning. Each perspective contribute some ideas, tools, each are having their own limitations also. Let us understand the computational perspective. In machine learning as an algorithm process, we focus basically on the algorithms, how to develop the algorithms and how to optimize our algorithms to perform best. We check the optimization techniques through like time complexity will be there, memory efficiency, memory management will be there. Then we develop the model and deploy those models. You can have examples like decision trees are there, neural networks or support vector machine is there. So here machine learning is about designing algorithms that learn patterns from the data. So this is from computational perspective. When we see machine learning from the statistical perspective, in statistics, we try to derive the inferences, like we have to develop the probability models. In probability, we see normally the data distribution, how much data is skewed, what is the average, mean, median, mode. So many things are there. We see the confidence intervals are there and bias and variance trade-off will be there. And some of the examples which are related with the statistics are like linear regression is there, logistic regression is there, Bayesian classification is there. So here machine learning is viewed as a relationship between the variables. How you are going to predict the values, how uncertain is the model. Okay, so from statistical perspectives, these are the things which they will take care of. Then we go from the data-driven perspective, where everything is seen as data. Like for example, data scientists, what they see, they try to extract the insights from hidden patterns from the large data set. They try to see what is hidden in that data set. They try to automate their decision making based on the data. For example, clustering is there. We will try to group, we will try to make clusters based on certain properties. We will try to go for anomaly detections in that particular data set. We will use it in recommendation systems. You will see recommendation systems are used everywhere in social media, in Facebook or in your Instagrams, where you will get the recommended friend requests and all. So here data is the main driving force. On the basis of the data, all the decisions are being taken by the organization. Okay, so it is used in business intelligence as well as in data science. So it is from their perspective. From engineering perspective, I want to design a machine, the best machine possible, which can perform and which is having like best optimization. There should be a scalability for those machines also, and a robustness also is taken care of. And if you see, the applications are there in industrial automation, medical diagnosis, IoT and robotics. Here we are building more practical ML solutions. One more perspective is from biological or cognitive perspective. So ML is inspired by the human being. So here we try to make machine who think like humans, like neural networks. You will be using artificial neural network, reinforcement learning, deep learning. So in biological or cognitive perspective, we try to have machines which will mimic the human intelligence. So we want machines to be more intelligent to take the decisions. So if we do the comparative study on the basis of the perspective, you will see every perspective is having a different goal. For example, computation is related with algorithm and efficiency. They see how we compute, how best we compute, how fast we compute. From statistical point of view, it's all about data distribution and the reliability. Is the prediction valid or not? From data-driven perspective, it's all about raw data and the patterns over there, dealing with the data engineers and other things. And what does data reveal? Okay. From cognitive perspective, it's all about human learning. Can machine learn like humans? For example, can they take decisions by their own? Machines, can machines think? Do they have the sentiment analysis type of a thing like we humans are having? And from engineering perspective, how we can deploy at a large scale. Now let us come to the layman's terminology of a machine learning. We all know how humans learn. Okay, if a baby is born, that time his memory is nothing. It's like a plain paper, white paper. Okay, nothing is faded over there. So his database is filled with zeros. He don't know anything. But with the time, he's seeing things. He's seeing the objects. He's recognizing the words. So he's all storing from his till he's grown up. So everything is stored in his database. So later on he is able to recognize like fruits, vegetables, his parents, his cousins, his surroundings. Okay. So it means human learn from their past experience. I will give an example over here. If a person is there, if a student is over there, let us say he's studying in a college, 18 years of age. If he know the spelling of the apple is A-P-P-L-E, apple, but he has never experienced that apple, he has never seen that apple. Okay, and if you are going to show him a grocery store and you just ask him, you go and bring one apple for him. So he will be confused that what an apple is. So he won't be able to bring the correct object. Why? Because he has not experienced it. So experiences is must. Experience is unless and until you experience a particular thing, you are not going to recognize it. Let us say, if there is a person, we will ask him that what is this object, and if he has experienced this particular object, he will immediately say, yes, I know this object. This is a car. Why? Because he has seen so many cars over there. He has seen so many bikes, so many vehicles over there. So he recognized. He can get it. He can fetch it from his database. So every human brain is like a database only. So whatever data set is there, if you ask him what is the model, maybe he don't know the model of the car because he is not aware of those things. There are people who know each and every model, engine, everything they know. Okay, so they are having more data in their databases. So the more data you are having in their databases, so it means you are going to recognize the things perfectly. Now let us ask the same question to these fellows. Okay, they are your childhood favorites, Tarzan and Mowgli. Okay, if you ask them what is this, they will be confused. They will laugh. They will be amazed to see what is this. Okay, and if you see in their database, this is actually their database. If you see in their database, there are only animals. Why? Because they have never experienced such object. Okay, and they have never kept that object in their database, in their mind, in their memory. So what will happen? They are never going to recognize these objects. Now the question is, how we make them to recognize these objects? Okay, so for that we need to give them training. So we have to show them such objects. Like car is there, we have to show them this is car. They will check there are 4 wheels in a car. Okay, and the car is closed from outside. Okay, so we have to show them this particular 2-wheeler, it's a bike or it's a scooty. Okay, once they see all these objects. Okay. Then if we ask them again, now we will see how it has affected their database. Now, if you can see, earlier only this much was in their database. Now this portion has been added in their database. Now their database has increased. Their data set has been increased. Now if you ask them what is this object, immediately they will say this is a car. Why? Because they have experience with. What about machines? These are the humans, we make them learn. We can speak. Okay, they can also speak, they can hear. What about machine? You know machines follow instructions or no? They don't know anything except instructions. Whatever instructions we give, we follow those instructions. Okay, and why we are using machine for such computation like subtract and addition, other things we are doing. Okay, because when anything runs beyond the human capacity, for example, in examination also, if a student is there, he has to calculate the log and other formulas. He will take the calculator with. Why? Because he wants to do things at a good speed. He don't want to waste time over there because he know his capacity or her capacity. Okay, so we use machines when we run out of capacity. We want machines to do such kind of thing. What we want actually, this is the thing what we want. Our machine should be able to identify the objects like we people do, humans do. Machine should predict the future prices. Machine should be able to recognize the places. Let us say, for example, I need an attendance system. Okay, instead of taking attendance one by one and spending 10 minutes on the attendance, I want machine to take the attendance. I want to save those 10 minutes of attendance. I can utilize it in the classroom. So I want machine to recognize my case. I want machine learning machines to understand the natural language, to check the grammar, to correct my sentences over here. These are all the things I want from machines. But how machines will know? They know the instructions only. That instruction also I have to give because I only created that machine. So what we actually do, what we have done with the Tarzan and the Mowgli, we made them to get experience with such kind of objects, to increase their database, to have more number of objects in their memory. Okay, in that way we made them to learn. Same thing we will do with the machines also. Let us suppose we are having a machine and we have to train the machine, like we train the Tarzan and the Mowgli. Okay, to identify a car, to identify that particular object. And the data, this is one, this is another one, this is another one, another one. You can have any number of objects in your database. This is actually called the data set. And the data set we are using to train the machine is called the training data set. So you have to provide the machine the training data set so that the machine will learn the way humans are learning. And we have to do programming also. We have algorithms. Okay. We have to execute those programs. In those programs, we will be writing different rules will be over there. And there are instructions which will be helpful to extract the patterns over there. There will be rules written in the program to identify the relationships between the objects. After we do all these things, we have a data set, we train the machine, our algorithm is with us, and our algorithm will help to infer the relationship between the objects. Okay. Then your machine, which is over here, he is saying, hi, I am ready now to recognize the things. Now he has experienced the things. Now he has experienced all these objects over here. So now his database is filled with all the objects. That is why whenever any student is going for a project, he need a data set. Train the machine to train the model. So a student should know that without any data set, he cannot create any model. So we can say that statistics, or we can say the data, it's the statistics, the backbone of machine learning. Without data, you're nothing, you cannot do anything. That is why you'll go for Cadwell or you'll go for GitHub. You will try to search a particular data set. So somebody has created that data set. If I have to recognize the digits from 0 to 9, somebody has already taken that data. He has already given that data to different people. You people write in different handwritings, 0 to 9. Amnesty data is there. There's a data set like Plant Village data set, where there are more than 75,000 leaves are there, different leaves are there. So we need data set to train the machine so that next time the train machine, if they observe such particular data, they will easily recognize it, like teeth movement. So this is the gist. We want to give a learning problem to the machine What is the first thing we need to do? We need to identify and create the appropriate data set. Okay, so this is the first step. Okay, unless and until this step is not complete, we cannot move forward. The next step is we need require rules like algorithms and programs, patterns, and the relationship capability in those programs to check the relationship between the objects. Okay, so once it is all done, okay, then your machine is ready to tell you that I'm ready. For example, if it is for the classification to check whether the mail is spam or not, machine is saying now I'm ready, I have learned the rules and the regulations. Now we can come up to the definition. What is machine learning? So we can say it's a field of artificial intelligence that teach the computer system to learn and improve from the data without being explicitly programmed. This is very important. Explicitly programmed. Because we don't do explicit programming over here the way we do with the traditional programming. I'll make you understand what actually that is. In traditional programming language, what we actually do, we write the program first. We check it with for errors, we compile the program and then we execute it. Okay, so we get the final output. If the output is not desired, what we normally do, we go back, edit the program. We spend days and nights to edit the program and try to get the desired output. So we keep on going into this loop until we get the perfect output. Okay, so let us take an example. So you just imagine that there's a robot. We want to teach that robot to recognize the fruits. Okay. And we are writing, because this is traditional programming, we are writing the rules that if anything is round and red, you call it as an apple. This is an apple. If anything is long and yellow, it is a banana. So these are the two rules which we have written for a robot to recognize. Now, if we are giving a particular picture to a robot, that particular picture will be of green apple. Okay, even though this apple is also round, but its color is green. And we give a spotted banana. But the rule is saying if it is long and yellow only. Okay. So even though these two things are apple and banana only, but your robot won't be able to recognize them. Why? Because it is going against the rules. We have long and yellow banana, but we are giving a spotted banana. It is written that if anything is round and red, then only it is apple, but we are giving a green apple. So here the humans define the logic explicit, but in machine learning we do the opposite. We feed the machine with the input, we feed the machine with the output also. Okay, and in return we get the model. What we feed as an input? We feed input as an image, apple image, and label will be as an output. This image is an apple or this image is a banana. And we will ask this robot to figure out the hidden rules inside. Because this is what we do in machine learning. We don't explicitly program over there. It is written once, then machine will learn. I can give you an example over here. For example, you know what is a spam. There's a tab in your Gmail that's called the spam. Okay, the job of the spam is, if any mail will come, it should check whether the mail is spam or not, unwanted mail or not. If it is unwanted, it should be going to the spam folder. Otherwise, that email should be going to the inbox. Let us suppose while creating the spam program, I gave spam only 4 words like lottery, 1, prize, and some figure, 10 lakh. These are my bags of words. So I train my spam with these 4 words. So if any mail will be having these 4 words, treat that mail as a spam mail. Okay. And we are also saying that these spammers, they will learn with the environment without explicitly programming. So once I have written this spam program, okay, now it became a small bot for me. Now it is in my mail. Okay. Now let us suppose one mail is coming and it's having some words written offer over there. So when I see the mail, because spam is not going to detect. Why? Because the word is not matching with any of the words over here. Okay. So when I see that mail, so many offers are there. So I recognize this is a spam mail. So what I do, there will be a small checkbox over there. I will check it and I will say, keep it in spam folder. Okay. So this is a trigger for the spam program that one mail is coming, it's a spam. So spam program is written in such a way, it will go through this mail. It will see how this mail has crossed, okay, my spam box, and it has went into the inbox. Why? Because there are only four words into the spam. If any mail is matching having these kind of words, it will be treated as a spam. Since here we are having a word which is offer, and it is not matching with any of the words, so spam is not able to detect it. But as a human, I detected it and I labeled it as a spam. Okay. Now again the spam program will be triggered. It will check all the words over there, and then it will see that, oh, there's some word over there which is offer. Okay. Now let me keep this offer in my bag. Now there is one more word added over there in the spam bag over there. Nobody has added it. Spam itself has added. So there is no explicit programming over there. Spam learns with the environment. So after 1 year, you will see instead of these 4 words, there will be some 100 words over there. Why? Because we have given the input that this mail is spam. Then spam is checking that what are all the words over there by using certain things like IDF, TF, IDF is there. Term frequency of a particular word. Okay. The thing is that it learns with the environment. There is no explicit programming in machine learning. So the question is, what is actually a model? Model means machine's understanding of how input is related to the output. How an input is related with the output, that is actually what we call the model. And this model is stored as a file where we are having weights and parameters. So an example is over here. For example, if we want to predict the price of an house, these two are the constants over there. This is the base price over there. And we have to calculate the price in terms of scap bits. Okay. Here the machine, your model will store these two numbers over there because scap bits keep on changing. Okay. So model means the machine's understanding of how input is related with the outputs. Okay. When you load this model somewhere else, the machine will use the same numbers to do the prediction. Like house prediction, if I have done house prediction in one particular area, I have developed the models, I have taken certain features into consideration, and the value of those features also I have taken into consideration. Now I have saved it. Now if I want to predict the price of another area, okay, like house price or a land price over there, I can take my model. Simply I have to give the figures. My model will tell, depend on the accuracy of my model, what could be the predicted price over there. Now we will move on to different paradigms of machine learning. There are 4 paradigms over here. Supervised machine learning, unsupervised machine learning, semi-supervised and reinforcement learning. You can see that their names itself suggest that what kind of learning it is. Supervised means somebody is there to supervise. Unsupervised means nobody is there to supervise. Semi-supervised means the combination, and reinforcement learning is feedback based. So what is supervised learning actually? We know learning cannot happen without data set. Okay, so in supervised learning, we need something called the label data. So if I am having a car as an object, I should have a label also which should mention that it is a car, CAR. If I am having a bike, I should have a label which should mention that it is a bike. This is what you call the label data. The object should be there and the label, the name associated with that object should be there. This is called the label data. And we have created, I already told you that what is a training data set. The data set which we use for training purpose, okay, to train our model, okay, and then this is the mathematical formula only, function only, okay, to train that mathematical function, to train that model, we call that training data set. So we have created one function over there, okay, we have a label data over in this database. Now the task is, we should devise a function which will take this data set, okay, data set is here, and we will keep one new sample for testing purpose, and we will see what is the output here. Okay, so this database will contain all the training data sets, and here we will give one new particular data which the machine has not seen, and we will see whether the machine will be able to recognize what kind of update is this. Let us suppose you can see from our database we have given 2 cars over there, 2 bikes are over there, okay, and this data set is over here, okay, and here we have given a new sample. You can see this particular yellow car is not there in the data set. Why? Because you want to test the machine whether it will be whatever machine has learned previously from the training data, whether they will be able to generate the correct output or not. Here actually we are doing the classification. The machine has to tell whether this particular object is car or a bike. So we have done 2 things, that it has to tell whether it's a car or a bike. So here it's giving exact output value, it's a car. Now here instead of car, you can see we are given a bus. But our model is saying that again this is a car. Okay. Since we have done only 2 classification, we have done only car and bike only. Based on the features, our function is saying it is a car. Why? It will be, maybe it is checking the number of the wheels, okay, weight and other things. On that basis, it is showing it is car. Why? Because when we have predefined class, we are having only 2 predefined classes over there. If you give any vehicle to this function, to this model, if it is a 4-wheeler, okay, it will tell you that it is a car. If it is a 2-wheeler, it will tell you it is a bike. If we have 3rd class also or 4th class also, that it should have taken this bus into that particular category. So this is the example of the supervised learning. We are having labeled data. So every data is labeled over here. You can see labels are already given here. Cow, camel, animal. This is our data set. Okay. And it will go through the algorithms and we train this machine through our algorithm. And what we are expecting that our machine should correctly tell this is elephant, this is camel and this is cow. Okay. So in supervision, what is the job of the supervisor over here? This particular thing will compare the results, because we already know who is camel, who is elephant or who is cow. We already know that because we have fed the data to the machine. It will compare the result generated by this machine and the result we already have with us. Okay. Then it will check and compare, it will calculate the error. Okay. That error will be propagated to adjust the model. If there is error, for example, if we are not able to achieve 100% accuracy, then we have to adjust the model. We have to check some parameters. You can see data set will go, we will retrieve the data, we will take certain features from the data processing will be there, feature extraction will be there, selection will be there, and it will be fed to the model. Then model evaluation will be done. Evaluation will be done on the basis of validation and the testing. Okay. If our model is accurate, for example, my model is being 97% accuracy, I can stop it there, I can deploy my model and I can monitor its progress. Otherwise, if I am not satisfied, if we are not satisfied with the model performance, we can go back, fine tune the parameters and we can check the features. If there are extra features, we need to remove the features, we need to add certain features. Okay. Those features we'll see in the next slides. What are all the features we can add, what are all the, how addition of the features will impact the model. Coming to the next category, I just want to give a glimpse of the next category, unsupervised learning. In unsupervised learning, we are removing the labels. So there are no label data over there. We have MEBs, so we don't know the labels, so we don't know actually the ground truth. We have these images only, okay, and the job of the machine is to identify the patterns. So here machine is actually checking, okay, here we are having 2 wheels. So it is like they are having common properties, let them cluster together. These objects, they are having 4 wheels, let them cluster together. Similarly, in unsupervised learning, you can see a purifier, air purifier, it is associated with car only, not a bike. Okay, so our machine should know these hidden truths. Helmet, it is associated with a bike only. So our machine should be able to do this kind of association. Another thing, based on the colors, our machine should be able to group them together, make clusters. This is what you call the unsupervised learning. Now let us come to the first model. We will teach a machine how to identify the vehicle type. For example, we are having two types categories over here. We are having cars and we are having different bikes over here. We have to teach the machine. Machine has to recognize whether this particular object is a car or it is a bike. So first we need to give training to the machine so that they will understand. So how we normally give the training? Okay, this is our machine over here and this is our data set. This is what we call the training data set. First of all, we will try to identify different features of our objects. Okay, and you can see we have a feature set over here. Wheels are there. So wheels are in bikes as well as in cars also. This is one of the feature. There is some height for both the objects. There is some weight for both the objects and color obviously. Okay. So these are the weights vector over here. Okay. These are the features. So we have taken 4 features. There can be different values for these 4 features. But you have to remember one thing, that every feature won't be helpful to recognize the object. For example, if I say I have seen a red object, nobody can say that whether I have seen a bike, a car or an animal. Okay. So such kind of features we are saying they are less important. So in our data set, we should try to recognize the features which are important and which are less important. Okay. Whether I need to keep that particular feature or whether I need to remove that feature. Unnecessarily, we should not keep on adding the feature. Why? It will increase the complexity in the model. Now we have taken 4 features: wheel, height, weight and color. Okay. And we have given the values also. Okay. Vectors also. 4 wheel, 6, its height is in feet. Okay. Weight can be in kgs and there is a color over there. And you can see we have categorized good features as well as bad features also. Bad features means features which are very less important. Okay. So wheel, height and weight. On these features, on the base of these features, we are going to recognize object. And color is very less important, so we might not be using this. Okay. So it means all features are not useful. So these are the values for each and everything. Now, it's not necessary that we should take all these features while training the machine. Okay. Now let us take one particular feature. Okay. Let us consider a single feature. Here we have considered number of wheels. And you know, in car there are 4 wheels. So 3 cars are there in our data set and 3 bikes are there in our data set. So bikes are having 2 wheels. This is our training data set. This is labeled data. So this kind of learning will be called as supervised learning, where we have labeled data. So on the base of the wheel, we have to identify which type of vehicle it is. Okay. Suppose there is the question over. This is training data set. You can see 3 cars are there, 3 bikes are there. Now I want to test my machine with this particular vehicle. Okay. This we have not given in the training data set. This is for testing purpose. Okay. You can clearly see 3 bikes, 3 cars are over there. And this is for testing purpose. Now my machine should tell me whether this particular item is car or a bike, because we are having only 2 classifications there. We are having 2 categories over there. So let us estimate how our machine will exactly calculate, how actually it will take the decision. Let us check the probability. On the basis of the probability, what type of vehicle it can be. Okay. So machine will check the probability. If there are 4 wheels, the probability, okay, it is 100% probability is that it might be a car. It will be a car. And if this vehicle is having only 2 wheels, okay, there is 0% probability that it is not a car. Same thing with bike. If there are 4 wheels, it cannot be a bike. There is 0 probability. And if there are only 2 wheels, then there is 100% probability that it is a bike. So the image we have given, so machine is checking the number of the wheels and it is seeing that there are only 2 wheels, and immediately it will give us the output that this particular object is bike. So this is based on the probability. We can do the same thing earlier we did with the help of the probability. We can do it in a different way. Okay. Here I have kept the number of the wheels 1, 2, 3, 4, 5. If the number of the wheels is less than 3, again it is going to be a bike. If the number of the wheels are more than 3, then it is going to be a car. This is another way of doing the same thing. Now let us suppose we will test our machine with one more image. Now our machine will be confused what type of vehicle it is. This is the training data set. We have already given training. Okay, so there are 3 cars with 4 wheels and there is 1 car with 2 wheels. There are 3 bikes with 2 wheels and there is 1 bike with 4 wheels. Now we have included other images also so that we confuse the machine. Now again if we go with the probability, now probability has reduced. Earlier we used to have 3 cars only. Now here we are having 4 cars. Out of that 3 cars are having 4 wheels. 1 car is having 2 wheels. Now the probability of car with 4 wheels is only 75%. Why? Because 1 car is having 2 wheels. So totally 4 cars are there. Okay. So the probability of every item is 25%. So 3 car means 75% probability. 1 car means 25% probability with 2 wheels. And there's a car with 2 wheels, the probability is 25%. So now we have disturbed the probability. If you see in the previous slides, the probability was 100% and 0%. So there was no ambiguity there. Now we have introduced the ambiguity over there. A bike with 4 wheels having 25% probability and a bike with 2 wheels, 75% probability. Again, I will tell you how to calculate the probability. There are 4 bikes. 3 bikes are having 2 wheels. 1 bike is having 4 wheels. So 75-25 ratio is there. Same is the cars. 3 cars having 4 wheels. 1 car is having 2 wheels. Now if I ask machine, what is this object? This is a car with 2 wheels only, as you can see. Okay. So it will check the probability of this particular item. The probability of a bike, because only 2 wheels are there, is more than the probability of car with 2 wheels. The probability of bike with 2 wheels here is more than the probability of a car with 2 wheels. This is what our machine has learned. Okay. So it might probably say that this is a bike. Okay, which is a wrong output. Since we have taken only one feature into consideration. You might be thinking that it's having a cabin and all, because we are taking only wheels, number of wheels. We are not taking any other feature. Out of 4 features, we are taking only one feature into consideration. So what we will do, here we got the wrong output, so we have to correct the machine. How we can correct it? We will introduce one more feature over there. Here we have introduced height also. Earlier we have introduced only wheels. Okay, since our output was wrong, the machine output was wrong, we have introduced one more feature. Why? We want to correct the machine. We want to take probability from 75% to 100% again. Now if we give same data set, now the probability of car with 4 wheels and height. Here we are taking height. Greater than 5 height means it's a car. Less than 5 height means it's a bike. So if there is H, it means greater than 5. If there is L, it means less than 5. So the probability of car with 4 wheels and a height greater than 5 is 100%. Probability of bike, let us say a probability of car we will take first. Probability of car with 2 wheels, okay, which in earlier slide it was given wrong, but with greater height, it's having more than 5 feet height is over here, okay. So again it will be treated as a car, okay. Same thing with bike also. Bike with 4 wheels and less height, it means this bike. Height will always be less, okay, and there is no cabinet over there. And car with 4 wheels and less height, the probability will be 0. Now if you see, we have removed the ambiguity. Now everything is again 100%, 100%, and rest are all 0%. Now again if we ask machine, what is this? Now machine knows the probability of bike with 2 wheels, here it's having 2 wheels, but the height is more. Okay, it is less than the probability of a car with more than 5 height. Okay, why? Because here it is saying it is 100% probability. So now the output will be correct. Now our machine is saying this is a car Why it is saying it is a car? Because now two features are included over here. One is the number of the wheels. Number of the wheels are 2. And height of the car is greater than 5. It is h. So this way we normally adjust the machine feature so that it will give us the correct output. So you have to test your machine with the data so that your machine should give the wrong result. Okay. Then you should come up with certain features which will help us to correct the machine again. Okay. For example, if you take height over here, okay, in this diagram, if the number of the wheels is less than 3, it will be treated as a bike. And if the number of the wheels is greater than 3, this side, it will be treated as a car. Okay. But again, if we take this wheel feature only, then it is wrong. Okay. But here we are taking height also into consideration. That is why you will see number of the wheels are greater than 4. It's not a car. Again, it will be called as a bike. So we have given one more direction here. We have given one more segregation here. You can see this line over here. It is segregating everything. 3 are cars with 2-wheeler car also is there. 2-wheeler bike is there. 4-wheeler bike is also there. So if we don't take height into consideration, okay, then our output will be wrong. Okay, with single feature. So if we are taking 2 features into consideration, then our output is correct. Our classification is correct. You can see the diagram also. If you are having 4 wheels, yes, go to this side. If height is greater than, then it is a car. If you are having 4 wheels, yes. If height is less, then again it is a car. So it is on left hand side. If wheels are not 4, okay, no. Then check the height. If it is height, again it will be in this category, bike category. If the number of the wheels are 2, then again it will be in the bike category. So algorithms for supervised learning. Okay. And I hope you will get benefited from this lecture. Okay. And in future also, we will come up with good lectures, good sessions also. And it will be based on these algorithms like K nearest neighbor, decision trees, neighbor, support vector machine, random forest. And on the regression side, it will be like linear regression, logistic regression, and the polynomial regression. Thank you.